It's hot, I'm miserable, I've got somewhere to be shortly. It's a great time to start a kit. I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. I have an electrifying kit, another one of those electrifying kits, but this one is kicking it up a notch because it does require the use of a flyback transformer. And it's got a way thicker manual than previous ones. So let's see what we can see. Ooh, loads of transistors. 3 MPN, 1 PMP. Well, what I'm going to guess is that it's just setting up a high frequency oscillation. And look, there you go. You've actually even got a you've got to wrap a bit of wire. Look around that. And there's your, I think that's your primary. That's your secondary, and then that's doing a dirty, great big arc. But I'm looking here. I'm not sure. It's kind of like we got to guess which pins we're going to have to use for this. This is out of my original Phoenix arcade cabinet from Cocktail One, Tatio. So let's see. It's showing here music coming in by the form of an MP3 player into the circuit, and then it's doing some stuff. But what you will notice, of course, that the circuit looks pretty bareboard. I was like, oh, this is nice and simple, but no, it's surface mount. There seems to be a missing diode. So let's start looking at stuff. Now, surface mount isn't really too difficult or too different than what you've seen me do before. Ooh, audio wire. Classy. This is odd, isn't it? That's a very odd package for a capacitor. Presumably it's going to fit somewhere. I'll figure that out at some point. A big old heat sink right there. What else have we got? Tell you what, let's zoom out so I can just tip it all out. Loads of little surface mount bits there still on their tape. So I guess if we're going to do anything, we're going to probably just put the surface mount stuff on. And look, a reclaimed international rectifier F2907Z. And that's weird because I thought, looking at the picture, yeah, there is some sort of surface mount transistor in action going on, so we're going to pick that up. It's weird they used that sort of international rectifier thing, but we'll have to see what it is, because clearly whatever it was worth reclaiming in order to make a kit from it. I'm going to use my previously containing acetone pot now for keeping all these bits in, and I suggest you do the same if you're working with surface mount, because you're going to get lost without it. Don't leave home without it. Right, so this is going to be a little bit more fiddly than we're used to. We've got to see if we can figure out here what we've got, because there are multiples of some things. So you've got 3 transistors and it's saying Y1. So I can see a Y1, a Y1 and a Y1. So there's 3 Y1 footprints on that, and I did see those 3 transistors right there. So we're going to have a go at those first. Now we could try a couple of different ways. I may have usable solder paste, and when I say may have usable, it's been sitting here for a good long time without any lid on, so it might have just gone rubbish. So I'm going to put it on this dinosaur, and we're going to see if I can actually, I'm using my palm here to try to push this syringe. No chance. Absolutely no chance. And that's the problem with this. If you buy it, especially in any quantity like that, unless you're using it frequently, there's the chance. See there, it's kind of dried out. The flux in it dries out, and you'll get like a big old ball of it. Right, so I've squeezed out the blockage, hopefully, but then whether or not it's going to get through the needle, I don't know. Ugh. Oh well. We'll still use some, but we'll just apply it straight from the fat end of the tube, just to show you how you do it. So I'm going to take that off. I'm going to zoom in. Have a look right here. Oh my. Okay, so I've applied a big old dollop there, and you can see it's bridging everything, it's over all the pins. Now if you've got a decent way of gauging it, and that comes from practice, we're going to find out soon enough, is that too much or too little. So there's our component there. And now's a good time, you see, to hit it with heat. So if you've got a hot air blower, that would be the preferred way. But I'm going to try to do it with a soldering iron, because that's going to be a bit more like what you've got at home. I'm just going to touch around here, and you can see, although it's not square, if that probably would do the trick. Right, so I'll tilt that slightly so you can see it. So that's it now sitting there. Pretty decently actually. I'm going to do another one here on this Y1 down here. So it just shows really you can just sort of get away with a lot. I mean, if you think about it, solder paste is kind of a flow technology, so it's designed to use, form like a little meniscus, and then surface tension pulls that component down. And because of the flux and the way it all works, like magic, it all kind of jumps off the silk screen and the solder resist. Right, let's try it with heat now. Try not to blow the component off the board. He said blowing it off the board. So we've got 2 dollops there and none here, but I actually did manage at least to recover that. Ah! Not sure why. I'm going to just hang on. Let's turn that down. I'm just going to turn the old airspeed down. Okay. So we'll try one more. Now that dollop is way too big. I think I can remove at least this much. It's a fair old amount. Right, let's try it with the now slower speed. Yeah. So what happened there was I actually put the component down upside down. Right, so you can see from that it was a pretty cumbersome way of doing it, but it's not the paste's fault, it's my fault for not having this nice and clean. But what you can do, you can literally just go dollop, dollop, put the part down, heat it up, dollop, dollop, put the part down, heat it up, and you'll be able to whiz through these. So I'm going to have a go and see if I can clear this out, because otherwise this board's going to take way too long. Right, I got a little bit of go out of this, and we've got our Y2s here. So it's weird, it came with 2 Y2s, but there's only 1 Y2 footprint as far as I can see. So maybe it's something you might blow up. So you can see I have to put quite a lot of force to get something out of this. And of course these are designed to be administered by a machine, so that's why. Human force is just about possible, and they do various makes of that. There is a kind of a, I don't know what it's called, it's something like an easy solder or something like that, quick repair, and it's a solder paste that is pretty hand administrable, if that makes any sense to you. It's got more, you know, flux or something in it. It flows really easy. So I'm just going to do this. I think I'm just going to try the soldering iron again. There we go. I hear a lot of shouting from inside the house today. Today is a kiddie's play date, apparently. Whew. And a bit of solder there. Nice. Right, so that Y2 worked pretty well. So yeah, I think that works okay with the old nib on here. Do 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 do. Let's try the old soldering iron again, I think. There is another little trick, by the way. If you've got a soldering iron and you've got hot air, what you can do is do what I'm doing here, where I'm just placing them with the iron, and they're alright actually. They'll probably electrically be fine, just don't look as pretty. But what you can do then is gently heat the whole board with the air, and they'll all snap into position. It's been about 10 minutes now, maybe less, I don't know really. I lost time doing this, but it's alright, all the bits were there. But I thought it'd be interesting to show you this thing, just because it's slightly different than what we've been doing so far. So I'm going to turn it this way. So ideally, I'll tell you what I did, by the way. All I did for the rest is I pretty much just did regular soldering on one pad, then offered the component, did one leg of the resistor or whatnot, and then went round that way. But this way I'm going to try to do this with a bit of paste, because it's a big old thing, and I'm going to squidge a bit onto the other pads, although they're less of a concern right now because you can always get to those. Put that there. Squish that down. So it's a big old squish right there, isn't it? You can see that. And then I'm going to just take the old soldering iron and I'm going to touch it on here. You can see it's starting to float, and that's because it's sitting on a bed of solder, and of course I didn't have it flat. I'm just going to keep it there with my tweezers. There you go. So I'm going to heat the other two pads. Looks pretty good. Oh, it actually jumped. The cheeky one. Come on, get back. Right. Done. That's not going nowhere. So yeah, it's looking pretty good. So once you got to that point, you can either apply some hot air over the board, or what I'm going to do is I'll just give it a quick quick squiz. And I tell you what, it is incredibly difficult working on this in this heat. I have a massive respect now for people who have to work in hot climes, and I can really see now why some of the countries, you know, we deal with in work, they have a kind of a shutdown and then just disappear off for like a month or two. Sensible, that's why. You can have a look, see what this board will look like, see if it represents the picture here. So there's the picture, and there's us. And I think that looks pretty good. I can't see any major faults right now with that. So we're just going to flip it over and do all the through hole stuff. Now this side looks way more fun because it's sort of through hole and big stuff. So I've put together the couple of little simpler, more mundane components, the LED and the ceramic capacitor. But we have now here this interesting format of cap. It's a 0.33 microfarad, 630 volts. I don't know if it has a way on it. I mean, I don't think it's sided. It doesn't look like it's an electrolytic, so I guess we just shove it in. So it goes through there. Ooh, that's so satisfying because it's just such a chunk. You know, it just goes in. There's only one way it can go in. That's that. And there's something I want to show you on this side too. I didn't notice it before I flipped over. You see this is tinned, but there's no solder mask on it. And that's because we're going to go over that with some solder to thicken it up to effectively increase the surface area. Well, not the surface area, rather the thickness of the signal layer on that. So it's nice and thick. So we'll be doing that in a moment. So there's really a bit of a challenge here. So you've got to get the heat sink on, and it's tapped. So you've got to screw your component to that and get it on. I think I kind of prefer to try to do it in one hit, or at least get it on loosely. So I'm going to start that here and give it a few turns. So it's loose, so it's manoeuvrable, but it's not going anywhere. Yeah, that was okay. And you can actually tighten that up now if you want. I wonder if that'll help hold it in place. It does actually help hold it in place. That's an easy one. I can hear my PC in the background labouring away in this heat. It sounds like it's suffering, it really does. Okay, good. So we're going to pop that there where it should go. Not, hang on a minute. Again, I think the heat's getting to me. I'm confused. I've confused myself. Right. That is a headphone thing. So that's going to go over there. Come on, you. Not enough hands, I'm afraid. Just getting a tack there, waiting for that to... Cool, there we go. If you've got some, get some extra flux on the board, it won't harm it at all. Looks like it could benefit a bit of that. So I think they've given us a few different power options. And I'm actually going to do this switch from the top because I can flow it in from around the casing. It looks like they've given us a jack for the power or to screw terminals. I might go with, I don't know, let's see what the power rating is first. If it's reasonable, like something I've got an AC adapter for, I'll go for the jack. If it's something a bit more serious, we'll go for screw terminals. Okay, and one more. Boom. That's our switch. So let's have a look at the old manual. It's looking like it wants 25 volts, so that seems a little bit unrealistic. Or is it 12 volts? Volts, 5 amps. Let's have a look here before we get our knickers in a twist. Okay, so it's showing here, this one's the optional one, which can have the jack on it. Seems to be 12 volts. That's kind of within the realm of something we might have on the shelf then. And then we have the screw terminals that are going to the primary of that transformer. So these are the last few things we want. I've zoomed you in to witness the last couple of tack solders. One more. Good. And what we're going to do, remember what I was saying about this here? I wonder why they've got that weird pattern. You see there's a weird pattern? I'm wondering if they're wanting you to flood fill that so much it's arcing over all that. Probably not. That would be pretty bloody thick. But let's just leave it at that. Okay, good! Scarily, it's like we're almost there. Ah, so hot. So hot. The board's like 1,000,000,000 degrees now with that bit of soldering. I'm just trying to get this electrolytic capacitor right way round. Okay. Ooh, that could be it. Could this be love that I'm feeling? So we need a bit of wire, and it looks like it's saying we need 6 to 8 turns here. So I've got a bit of an old power supply. I'm going to fetch off some of its wire. So the longest piece we've got is black. Let's do this thing. It's electrifying. 1, 2, 3, 4. 4. Let's even get 2 on the other end. 4, 5, 6. Yeah, that's pretty good. That's pretty good, she. So I'm not sure on the necessity of this being neat though. They've managed to keep theirs quite neat. So you could put a piece of tape around that if you're concerned. I've noticed they've got this sort of spark pluggy thing, and it's very similar to what you get in a boiler, like an oil boiler. on the igniter circuit. So this could probably make a good oil boiler igniter circuit tester. Okay, good. So on, off, off, leave that off. We've got this whole thing now, we don't know which one it is. It's showing one wire. One test we can do is when this is running, we can hold this near the bottom and see which one is doing the old arcing for us. And that's probably about as close as we can get to it. Probably as safe as well. So I'm just pulling that off here. There we go. Got a bit of exposed now. Get some sound going on the old phone. I think we're almost in business. I'm assuming we're going to need the sound kind of early on, for example. So I'm just going to play some YouTube free music. Now I don't know what's the chances of this just working. Doesn't seem to sort of respect the fact that I've got my headphones. It's weird sometimes, this old phone. It just sometimes detects them, sometimes doesn't. A bit fussy. Right, so we've got that. And then the last thing is our power supply. It's connected to my bench power supply, which is currently at about 13 volts, which should be fine. So we'll plug that in there. Okay, right. Dangerous. This wire is so stiff. It's just pulling everything across the bench. Right, so we've got the music playing through the headphones. This is turned off. That's actually, I'll turn it on, but the bench power supply is what's controlling that. I'll turn that on. Okay, so this is apparently on and running. I can see the LED there is on. I can't see if anything's kind of arcing or sparking. So far, it's not doing anything too scary. Definitely it's on. Right, I'm going to start investigating all of that first. But at 13 volts, it's using 45 milliamps. It's not much power going through it right now. I'm just going to turn the volume up on my phone real quick, just in case. But no, nothing so far. Okay, I'm not sure what happened. I think it was just a problem with the switch. But whoa, definitely doing something now. That was weird. Whoa, I can feel it. Holy smokes, that's a big arc. Look, did you see that? How big that bloody arc is? I'm almost scared now. When this thing's running, you can actually hear all of this. Right, it's definitely going. I can actually hear the music, interesting enough. That's pretty cool, I have to say. Now it could be that my power supply isn't providing the full 5 amps, but look at the size of that. Woohoo! you can actually hear it just through the little arcing to the air, but I can see the bench power supply is maxing out at 2 amps. Woo! Right, I think I'm going to come back when it's a bit darker and we'll film that a bit more accurately. That's scary. Right, it's a bit darker now, so I've just turned it on, but I haven't heard that high tension arc. So basically, I've noticed my power supply is struggling to get this going, but when it does, you definitely kind of hear it, know about it, feel it. So I've got music playing on the side now. Going to turn it on. Nope. Not quite. It's not quite getting that sound. Ah, there we go. So there's a hiss now. It's hissing like an angry snake. As you can see, there's a glow potentially. Ah, you might not be able to. I'll zoom in. Oh. Camera's having trouble focusing on that. Tell you what, I'm going to try putting the lights on. See if the camera's going to focus. I tell you what, I think the reason the camera can't focus, because I can see it's got a screen basically on the camera, which is a touch screen. It looks like a million fingers touching it at once. It doesn't like that. It's time to go manual, guys. Full manual focus, right. I'm going in. There you go. I don't know why I don't do this normally. Let's bring this back into the middle of the frame for you. So I'm going to check the volume on my phone. Can't hear the music. Because do you remember the other one we had? You could actually hear the music in it, but it could be a sweet spot here. But look at that, that's crazy. That's like a constant arc. Wow, that is amazing. I'm kind of wondering what would happen if you had a piece of paper in between it. So let's leave that down there. Still can't, I can hear it fizzling, but no music again. I've got my piece of paper. I'm going to put it in between. Oh, look. Definitely blowing holes in the bit of paper there. But if you've got plates, 2 plates, and hook this up, I bet you'd have a crazy ozone generator from that. So there you go. Hope that's been of some interest to you. It's an interesting kit. My power supply can't even handle this. So if you've got the full 5 amp power supply it's saying to use, like I've got a car battery, you could hook that up. I imagine it should be insanely cool. Maybe you'll get it to make sound. In fact, why don't I adjust the voltage? So I'm actually adjusting the voltage whilst it's running here. Yeah, you get a bit of a difference. So I hope that's been of some use to you. Please ping me on my Discord. Come and chat to me. I'll speak to you soon. As ever, thanks for watching.